Thanks, Saulis. So, hello everyone. I am Vaidas Ulenskas, GIS and BIM coordinator, and today, together with my colleague Urmas, BIM and AIM coordinator, we will talk about GIS and Rail Baltica, what we're doing and what is our future. So, we both are part of Virtual Design and Construction Department and at RB Rail. RB Rail is a Rail Baltica project coordinator. For those who are unfamiliar with this project, so Rail Baltica is a greenfield rail infrastructure project with a goal to integrate Baltic states into the European high-speed rail network. The whole length of main line is 870 kilometers. And as you see, it will connect all main cities and airports. And during design and construction phase, Rail Baltica main line is split in 11 design sections, 4 in Lithuania, 4 in Latvia, and 3 in Estonia. Today we're talking about digital Rail Baltica, so just brief introduction to our common data environment. So it has 5 major parts. It's data model drawing management, asset information management, GIS, planning and scheduling, and context claims and variations management. To manage all this common data environment, we're basically using 3 softwares. It's a Bentley ProjectWise. For GIS, we're using ArcGIS Enterprise and ArcGIS Pro. And for planning and scheduling, we're using Oracle Primavera P6. And since we are a virtual design and construction department, our aim is to make sure that all these parts are integrated and working together. About GIS, so GIS, of course, we want to be take a significant part of Rail Baltica digital twin. It's our main goal, and actually 2 years ago we defined main areas where we want to focus on, and I think it's still relevant up to date. So it's a data management system, so we are using GIS not only collect and create the data, but also ensure the data accessibility and interoperability. We are not the only one company in this project. There are beneficiaries, there are designers, there are implementers. So we use GIS to connect all these parts together and just share data between each other. Of course, we cannot forget in public. And probably everyone will agree that GIS has the power to provide information to wider audience. So public maps is also on our list. But we cannot, as a coordinator, we can't think only about today, we're also thinking about the future. So what we are working now is we working on strategy, how we will use GIS for construction process, how we monitoring the construction. We're also thinking about future infrastructure manager, so everything what we'll create will be usable during operational and maintenance phase, and I believe Urmas will talk about it later. And of course, we cannot forget our employees. So most of GIS users is not a GIS specialist, so we provide trainings and support services. Another very important part is data interoperability. So at the beginning and during preliminary design, value engineering stages, the main data source was DWG drawings. Currently, we are focusing on and finding a ways how to extract data from BIM models and use it as a main data source. But so let's say 2 main data types that we are using is a DVG and EFC for BIM. But we're also working with aerial photography, laser scanning data, land XMLs. Of course, we have a big Excel fans in our company, so part of our data also comes in Excel tables. So GIS job is to integrate everything in one system so everyone can see it and can use it. Now about our project. So web maps is a main area where we are focusing because WebGIS is the interface which we use to communicate with our colleagues, our partners, and share the information. And as I mentioned before, mainline is splitted in design sections, meaning that each section has a different project manager, different working teams, different designers. So we use GIS to collect everything in one place and show it. So basically, GIS is an environment where everyone can see the whole picture of our project. And of course, it's not enough to have the data which is provided from designers. We also have to think about what is around Rail Baltica. So another big part of GIS teamwork is to provide third-party data. So it could be protected areas for our environment team. It could be fluid maps for our hydrology team, basically everything, forest data, land plots, everything what is necessary for our colleagues to be very well informed. So this is our main, but not the only one area. Monitoring and reporting, actually we are using dashboard for that. And it starts at the very beginning with a site investigation phase. And then we use the ArcGIS dashboards to monitoring site investigation progress. But now we're thinking to use ArcGIS dashboard and to put it in higher level and provide information would be useful for those who are making decisions. So it means that we must have not only technical data, but also statistical data in GIS. And that's why, together with Esri and GIS Baltic, we started an integration project between ArcGIS and P6. As I mentioned before, P6 holds all the schedules, all the time data. So those who see the data on P6 know the project future, and this integration allows us to connect time data with location intelligence, which I think will create very useful and very powerful dashboards and allows these smart people to make good decisions about our project's future. We cannot forget on field maps, field apps, because our project is a greenfield project, so we are also using field apps. For example, ArcGIS Explorer. So it helps us to see the data and bring the data with us. So for example, if our colleagues are on site visits, we can just open the phone and check what is designed at the place where they are standing. We also use a Q capture for photo fixation. Our geotechnical team is using Survey 123 to ensure the site investigation quality control. But I believe that the golden age for field apps will be during construction phase. We are working on strategy. We are thinking how we will use field apps to collect information directly from construction sites. So we could get information about what is happening on constructions as soon as possible. Actually, I noticed that in conference agenda, we will have a presentation which states that Earth is not flat. And we also know that. Our designers also know that. So 3D mapping is also on our task list. And now during master design and detailed technical design phases, we are receiving pretty good quality BIM models from our designers. So it allows us to think about 3D mapping. And our long-term goal is to have a global 3D map for the whole line. And as I mentioned, we are coordinator, but so in such mega project, communication between coordinators and implementers is very important, and this is a really nice example how we can work together. So Rail Baltica Estonia is an implementing body in Estonian, and we are not only working on the same GIS environment, we are also sharing our data and our knowledge with each other. So it allows us to save a lot of time because we don't have to duplicate each other's work, and we can create a really awesome solutions. And this is just a few examples what RB Estonia is working on. So good news for all Estonian friends. If you would like to know what is happening with Rail Baltica in Estonia, feel free to visit RB Estonia webpage and you will find a public map. It's publicly available, so investigate it. It has a lot of information, and on the bottom right, you can find the RB Estonia GIS specialist contact, so do not hesitate to send the feedback to him, good or bad, everything is welcome. And another also very fascinating project, they already started work with 3D. As you see from the slide, it's not only our BIM models, but also his maps is enriched with 3D data like 3D buildings. Also there are forests, so it looks pretty real. Pretty realistic maps, and I hope that it will be a very good start for our global 3D map. And personally, my most favorite and most interesting is land acquisition GIS map, because land acquisition is very important process in such projects like Rail Baltica, and at the same time it's very complex. And RB Estonia, I am looking forward to see how RB Estonia will use GIS to manage this process. So yeah, basically that's all what I wanted to show you today. And actually, we started GIS implementation 2 years ago, and a lot of was done. And I can say that GIS become an important part of Rail Baltica, and in the future it will be even more important because smart guys made smart decisions and decided that asset register should be implemented on GIS. So now I would like to give a floor to my colleague Urmas, who will talk about GIS as an asset register. So Urmas, floor is yours.
Thank you, Vaidas. In my previous life, I have sold and supported facilities management software for 20 years. And yes, it was integrated with Esri GIS also, but we used Esri only to show the dots on the map. But my challenge was to tell to the people that Excel is not a database and you should have the information in the database organized. Now my main task is to tell to the people that GIS actually is a database. We started with the Sustainable Asset Management project in year 2020, so 1 year ago. We did evaluation of multiple softwares. And actually the task, what we required, was rather simple in my opinion. We wanted that the software would import the IFC models, the geometry and also the attributes into the database. Also, it's important to visualize the objects on the map and support linear asset management because, as you know, railway is a linear asset. Unfortunately, most of those very popular softwares failed during our proof of concept project. But luckily, Esri finished with success. And so with the support from our management board, we started the project last year. They advised us to establish a technical working group to gather information from different parties. And we have multiple parties. As you know, the Rail Baltica project runs through the 3 countries. So we hand over our structures after construction or also already before the construction to the local implementing bodies, meaning respective organizations in Estonia, Latvia, and Lithuania. So it is really important to enforce also the codification rules that are introduced in our design guidelines. So we created the asset registry or asset register process. I will not tell about the details, but I will present our results and process so far in a little bit reversed order, meaning showing at first the results and then telling the theory behind it. With the cooperation with the Estonian Land Board, this map was created by Rail Baltica Estonia, by Tõnis, who was mentioned before. The blue areas are the land plots and their information from Estonian Land Board. The yellowish area is the footprint of an aqueduct. And we see that how nicely that aqueduct fits on the land that we have already acquired. The red dot there in the middle is the point type information about this particular aqueduct. As you see there, the local name, the functional classification of it, the type, and the rest of the information that is coming from the database. A practical example from a different crossing. The green areas are the areas that we will acquire at a certain point of time. So the process is ongoing. But the red arrows point to the gray areas, meaning there are some land plots that are not included into our process. So the people who are dealing with the land acquisition could act based on that. as all the information is coming from the database, you can click on the objects and see the information about particular structures. About the classification. We have here 5 levels of logic. So the highest level is the country level, then comes the design section level, design priority section level, and submission package level. What is submission package? Our designer have the design contracts, and they have to deliver certain information at certain times. Very often in submission package is just one object, but sometimes there are, for example, 2 aqueducts and 5 culverts plus some melioration in one package. So we track the information about those packages. And in the small print, we have unique codes assigned to each sites. And if it's a value engineering phase, then we use the dash between the 2 textual symbols and the numbers. So we request or require actually that all related parties will fill in their information with a proper structure. And that is really important if we're talking about integration with ProjectWise and Primavera P6. How we gather the information, as usually we have lots of Excels and people are filling in those Excels. I provided the template to our project managers who did in that filling in the data. As you see in the columns that are on the right side, there are different dates, master design planned, master design actual, and so on. They filled in that data and also connected the information from submission packages to the individual sites. And what was a big challenge is to tell to a normal human being that the computer does not understand if you are writing BP -08, BP8, BP8. For you, it's the same, but for computer, you have to write it down in a standardized way as BP08, for example. It is really great capability of Esri ArcGIS to process data automatically. That is done by Python scripts, and we use Jupyter Notebook for that. We take the IFC file, the 3D model of the structure, and import that into the multi-patch layer. For regular, normal human beings like me, it means 3D data. Then we convert it to the footprint, which is then polygons or for regular people, 2D picture. And that will then convert it into 1D or into the points. We use also scripts to manipulate or change the titles of the fields. Why we are doing that? I always like to tell that I am a lazy person and I prefer to use the out-of-the-box capabilities of different softwares. So Esri has the interoperability extension, which actually can handle by default only 4 attributes. So we are changing the names that are in the models into the field names that are used in the GIS database. How does that information look in the models? You see with the green arrows, we have marked the attributes that need to be transferred into our database. By default, most of the IFC programs that are foreseen to take a look and look at the details of the models, they use the identification information which is by default not filled in, as it is not required in our design guidelines. And as the designers are very busy, they do only the things that are mandatory and not the optional stuff. So I am using the software called SimpleBIM to read the information from the Alber data property set into the element specific information attributes. We really strive to that all the information, the most critical information, will be in the database. So Esri provides the opportunity of Excel-like editing of the data. So what you do is you click just or double click on the date field and you put in the correct date for the attribute you need to be filled in. And that is reflected immediately then in all the reports that are used. A couple of screens about practical implementations. Here is 3D data visualized, and also we have the data that comes from the database. With GIS, you can do different kind of analysis that you are not able to do in Excel. For example, here we can visually verify that all the object classification codes, OCCs, are in or related to the proper structures. You also can find faults in the design. Here, for example, we have 3 elements that were just converted into footprint as squares. So we sent that information back to our designers, and they then improved their drawings or models, to be more precise. What are the next steps? During the design phase, the designers are obliged to provide also the maintenance information. So we systematize that maintenance information according to the element types in the GIS database. So that would be a great basis for the later stages in facility management to plan the preventive maintenance work. We are using UNICLAS 2015 as this is described in our design guidelines. But also I want to include the dictionary connecting the types to the Construction Classification International. This is a new classification initiative with what we started a couple of years ago, and now included parties are the Nordic countries and also some countries located south of us, like Poland and Czech Republic. That's actually it from our side. I want to thank you and looking forward to your questions later.
Thank you very much.